Our next presentation today is from Tony Samarco from Device Solutions, speaking to emergency digital paging, improve situational awareness and reliable redundant communications with advanced television systems, Committee 3. Tony?
Thanks, Chris. Hello, my name's Tony Samarco. I'm the Director of Technology Strategy with Device Solutions and PM for the project. We're thrilled to be invited to the 2024 First Responder Showcase to update you on the progress of our Phase 2 CRPP contract for emergency digital paging over ATSC 3 Next Gen TV. ATSC 3 is the latest digital broadcast standard being rolled out by public and private TV broadcasters in support of higher resolution video and more secure datacasting services. Our goal is to provide a secondary means of reliable emergency digital paging communication with a low-cost, low-power ATSC 3 mobile receiver to improve situational awareness. So during I-Corps, we interviewed over 100 firefighters, medical responders, emergency equipment manufacturers, and state emergency IT departments to focus on what needs to be addressed by a new paging technology. Two-way digital radios are expensive. In rural fire departments, sometimes only the officers can carry two-way radios, so responders rely on their pagers or cell phones with paging applications. Today's emergency paging can limit situational awareness for emergency responders in a number of ways. There are coverage issues, reliability issues with system interruptions, latency, which results in delayed delivery of messages, and non-secure data path, which can limit the ability to send additional information regarding patient health. There's a minimal interoperability to neighboring jurisdictions and statewide systems, and it's also not viable to solely rely on commercial cellular service for mission-critical communication. So E911 call centers are largely non-standardized and unique for each vendor installation, which has made interoperability difficult, and normalizing data from multiple vendors is an enormous challenge. The ATSC3 IP datacasting architecture enables a straightforward path to integrate a reliable secondary means of communicating FEMA, IPAWS, WIA alerts, as well as the ability to use ATSC3 broadcast as a backup to GPS, which we'll discuss later. So who would benefit? State and community, county emergency services, organizations that rely on real-time emergency notifications, such as first responders, firefighters, police, and ambulance services, organizations that need reliable primary or backup emergency paging systems, federal organizations, such as the Department of Defense, FEMA, U.S. Coast Guard, and AWARN, and NOAA alerts can also be ported to the digital broadcast for reception by these mobile receivers. We are also exploring additional applications that benefit organizations beyond emergency paging. For example, providers of critical infrastructure that require precise timing and location as a backup to the GPS system. So customer requirements, referring to the needs that we discovered in the 100 plus interviews conducted during I-Corps, we focused on critical customer requirements. Those are reliability, redundancy, and data path is essential. The latency from when the message leaves the CAD to when it is received by the emergency responder should be less than 10 seconds. We must improve on the delays that come with the page out of the existing tone sequences today. Coverage should be 100% with in-building penetration. The data must be secure, which will enable the transmission of protected data to improve situational awareness. There must be regional statewide interoperability to mitigate supporting multiple systems or having to carry multiple radios, and the ability to provision the receivers to only receive the desired pages, and the delivery of video and audio streams to help improve situational awareness, such as up-to-date real-time delivery of digital imaging or pre-plans rather than having to carry binders with hard copies. So a few words about ATSC3. It's the next generation of terrestrial television broadcast that offers a wide range of improvements for the delivery of over-the-air broadcast to a large area via high-power, high-tower transmission, and it's being widely deployed across the U.S. as we speak. With an IP backbone, ATSC3 allows not only HD television broadcast, but the broadcast of data streams in a robust and efficient manner. PBS North Carolina has launched 2 ATSC3 broadcast towers which we utilized to test the emergency paging solution, along with one broadcast tower provided by Capital Broadcasting in Raleigh, North Carolina. We successfully demonstrated ATSC 3 emergency alert and public safety datacasting capabilities by using ATSC 3 standard protocols to develop and optimize the public safety prototype system over the ATSC 3 transmission. Through this work, we demonstrated that yes, ATSC 3 broadcast is a reliable transmission means to deliver emergency dispatching over a large area with superior coverage, penetration, and reduced latency. As you can see on the picture here, we even received pages from over 78 miles away from the broadcast tower. So the transition from analog TV to first generation ATSC 3 to this current ATSC 3 generation is really revolutionary. With ATSC 1, PBS North Carolina broadcast 4 television stations, 1 in high def and 3 in widescreen standard def, where ATSC 3 enables increased data delivery capacity with high efficiency video coding, which greatly reduces the amount of bandwidth needed for broadcasting HD video. The result is a nice large pool of data that can be utilized for other purposes. ATSC 3 allows us to create new physical layer pipe definitions, which can be custom configured for specific use cases. For example, PBS North Carolina, as you see in the picture here, is broadcasting 4 PLPs. PLP 1, as defined, can carry the 4 HD TV channels. PLP 2, for example, can be used for educational datacasting to students with homes without broadband connectivity. And then we defined a new PLP, PLP 0 in this picture, to carry the emergency paging data, which utilized QPSK modulation and additional forward error correction to maximize the performance of the emergency paging while minimizing the bandwidth required. The PLP can also be used to carry other applications like the FEMA and the WIA data that we discussed earlier. The really cool thing here is the modulation and coding schemes for each PLP can be adjusted real time to account for traffic spikes or to optimize the coverage or penetration while not interrupting the broadcast of the broadcast carrier. So here's a look at the solution that we provided. So an emergency page comes into an E911 call center, and we developed a normalization server which standardizes the CAD data received from multiple E911 call centers and manages the paging traffic to be broadcast and sends the paging traffic through custom APIs that optimized for the emergency paging solution. The data is encrypted to ensure secure communication and sent to the ATSC3 broadcast. With very low latency, the devices then receive the paging data for which they are provisioned. The low-cost receiver reference design that we built are twofold. We made a paging receiver with a speaker display, UI, navigation, and menus more aligned with traditional pagers in use today, and an ATSC3 receiver-only version with a Bluetooth interface that pairs to a smartphone application, which takes advantages of the capability that's native to the smartphone. Turn-by-turn map directions, text-to-speech, and custom alerts, for example. Receivers are provisioned to filter the data broadcast to only present the pages desired to the end user. For example, only show me pages for my fire department or my county, or show me everything from these 3 fire stations in my neighboring jurisdictions. Both receivers provided better situational awareness and a more reliable, secure data path with low costs compared to today's two-way radios. So let's compare the existing technologies. As ATSC3 continues to be rolled out, coverage will continue to be improved over the existing systems. Our test partners, PBS North Carolina and private broadcasters, Capital Broadcasting in Raleigh, have proven to be extremely reliable with no downtime and astounding coverage and flexibility. The ATSC3 broadcast provides redundant data paths to existing applications and improves ISO ratings. The reduced latency from when the CAD receives the data and it leaves the dispatch center, our testing in live markets have shown less than 10 seconds of latency, providing an advantage over existing analog voice paging and cellular-based paging systems. The secure data improves situational awareness, and the IP-based paging data is easily filtered. Interoperability, as the broadcast covers a much wider area, pages from neighboring departments can be received by simply programming the devices to receive the data from the other jurisdictions. So we are exploring additional applications that can be served by the broadcast technology beyond emergency paging, but still related to emergency services. FEMA, WIA, and NOAA alerting, and real-time data to drones to ensure delivery of flight critical information and TFRs, temporary flight restrictions. And of course, it provides critical infrastructure and provides critical infrastructure manufacturers with precise timing and location as a backup to GPS. So adding connectivity of standardized nodes like iPause Open, for example, to the existing ecosystem allows our normalization server to aggregate and augment with additional data provided by any source with an IP link and send the data to the transport encoder with a custom defined PLP to deliver the service to our receivers. Small ATSC3 receivers can be mounted onto specialized devices like drones and provide critical real-time data to existing avionics interfaces. So a new secondary, secure, reliable data path is extendable to these multiple organizations at a much lower cost by using the existing infrastructure. And yes, ATSC3 is downlink only, which is certainly acceptable for certain applications, but devices with ATSC3 receivers can also be equipped with an IP connection, such as cellular, Wi-Fi, or Ethernet, for example, to provide an uplink data connection when needed. So a little bit about the viability of ATSC3. Yes, it is certainly dependent on the rollout of ATSC3. According to ATSC.org, there are over 80 markets covering over 80% of the population on air now with ATSC3, with more coming in 2024. And business intelligence advisors have projected non-core data casting revenues, so stuff other than TV, reaching $500 million in 2024 and between $6 and $15 billion by 2030. Huge market potential. So with respect to our project, what did we accomplish in phase 2? We built 2 models, as we discussed, the low-cost, low-power ATSC3 emergency receivers, the standalone and the companion device. We developed a prototype normalization server that connects to multiple PSAPs, normalizes the data, and then forwards it to the ATSC3 transport encoder to be broadcast. We successfully performed live end-user field testing with firefighters and emergency responders with real-time pages across the state in 3 distinct regions, coastal, Piedmont, and mountains, over multiple months. And we validated the receiver's antenna performance at each location, each of those locations having their own distinct challenges of urban, distance, penetration versus trade-offs with different mod cods in mountainous regions and repeaters with translator sites. So very robust. Our receivers performed exceedingly well compared to the existing solutions. There were no missed pages observed, and the latency was greatly reduced, and the end users were very pleased with the coverage and the reliability. So in this picture, you see 2 very happy end users from Eastern North Carolina that participated in our live testing, from the Winterville Fire Department Fire Chief and Lenoir County Emergency Services Director. They continued actually using our system for additional months, even beyond the testing period that was defined, because they were so impressed, and it actually extended the coverage of notification for their volunteer firefighters. So to decrease the commercialization timeline and prepare for commercialization, we applied for and received a CRPP award in Q1 of this year with a period of performance of 1 year. And our focus of the CRPP is to implement channel scanning that allows the receiver to intelligently select the optimal broadcast signal. And that optimal doesn't necessarily mean the strongest, but the one that services the needs of the area that we're operating in. We're also logging additional data as the page moves through the ecosystem so we can evaluate system performances and potential areas for improvement. And we are also extending the testing to live broadcasters outside of the state of North Carolina. And further our efforts with commercialization partners for the actual devices and for the normalization servers. So phase 2 was successfully completed, and our PP was awarded as we move towards commercialization. We're excited to be engaged with PBS affiliates in Ohio and Kentucky and WNET in New York, who is broadcasting ATSC 3 on their antenna, 1,600 feet atop the One World Trade Center. And that'll be a really interesting RF environment to look at reflections in multipath. So our value proposition is being the technology supplier and licensing the technology to our partners for the design, manufacture, and distribution of the end product. And key to the success is securing an emergency equipment partner with established market positions and distribution networks to integrate the technology into their portfolio. And we're working with partners on ATSC 3 chipsets and RF tuners to make sure that we have a low-cost receiver module development to expand to markets beyond emergency paging to service other emergency organizations, and standardizing the formats coming out of the PSAPs so we have a much clearer path for onboarding new PSAPs. So to wrap up, we continue discussions with emergency equipment providers to support new grants and funding opportunities for emergency services. In addition to the receiver, we're focusing on partnering with normalization server providers and enabling low-cost, scalable solutions for commercialization. National exposure at ATSC 3, NAB, and DHS publications feature stories are really helping drive opportunities and additional use cases. And please reach out to us and share our project with your contacts in the first responder community to help us save lives. So a little bit real quickly about Device Solutions, co-founded in 2003 by Chris Lamb, and we are in Mooresville, North Carolina by Research Triangle Park. We provide wireless radio integration and antenna design, and we have longstanding relationships with manufacturing, data hosting partner firms to develop end-to-end solutions. So here's our contact information. We're looking forward to your insights and continued support. And at this time, can answer any questions.
Great, Tony. Thank you.